हेलो स्टूडेंट्स। ऑनलाइन क्लास में आज हमारा टॉपिक रहेगा प्रोजेक्टाइल मोशन। देयर इज ए प्रॉब्लम ऑन प्रोजेक्टाइल मोशन दैट आई हैव टेकन हियर। दिस एरो रिप्रेजेंटिंग विंड इज ब्लोइंग। यहाँ से इस साइड से विंड ब्लो कर रही है अलोंग एक्स एक्सिस बट विद डिफरेंट स्पीड। और एक प्रोजेक्टाइल, यू नो प्रोजेक्टाइल इज टू डायमेंशनल मोशन। यहाँ पे किसी बॉडी को हम u वेलोसिटी से इनिशियल वेलोसिटी से अपवर्ड थ्रो करते हैं, तो वी हैव टू फाइंड द टाइम ऑफ फ्लाइट एंड हॉरिजॉन्टल रेंज। अगर ये विंड ब्लो नहीं कर रही तो इट्स वेरी सिंपल प्रॉब्लम। टाइम ऑफ फ्लाइट everyone can easily calculate, but this is not as simple as it appears in the first place. What is the basic approach to deal with the problems related to projectile motion? You know projectile is a two dimensional motion, तो उसके अंदर हम कैसे करते हैं? We divide it into two dimensions. Suppose this is x axis, this is y axis. अगर हम किसी चीज को स्ट्रेट वर्टिकली अपवर्ड थ्रो करते हैं विद वेलोसिटी u, तो ये वापस जो है मैक्सिमम हाइट पे जाके वापस ग्राउंड पे आ जाती है। तो इट्स टाइम ऑफ फ्लाइट इज वेरी सिंपल, 2u/g। एवरीवन कैन कैलकुलेट इट। नाउ इफ आई थ्रो एनी प्रोजेक्टाइल एट एन एंगल थीटा, देन विद a velocity u, तो इट्स वेलोसिटी along x axis is u cos theta, along y axis is u sin theta. So if I take the motion along vertical axis, to replace this u by just u sin theta, we can calculate the time of flight in this situation also. So time of flight in this situation will be 2u sin theta upon g. In this situation there is no horizontal range, the body will fall at the same place, but in this situation this velocity that will remain constant because there is no air drag, just like in this situation यहाँ पे कोई air drag नहीं है, तो ये constant speed से इस टाइम के अंदर इस प्रोजेक्टाइल को यहाँ पे जाके फॉल करवाएगी। and the distance from the point of projection to the point at which the projectile hit the ground surface, that is horizontal range. तो r is equal to, that is u cos theta into capital T. When you will solve it, you know the formula, u square sin 2 theta upon g. Everyone can calculate it. But can you apply this formula in this situation? No, not at all. What is the reason? We will analyze the problem in detail. Okay. First we have to see whether the velocity along x-axis in this situation is constant or not. It is not constant. The ball या any body which is thrown upward, it will experience a drag, air drag, and that air drag is increasing. You know, speed of the wind will be the speed of the ball along x-axis. So the speed is along x-axis is changing. So we cannot say that this speed is constant. So how will you tackle this situation? Let's start. Okay. You know, velocity along x-axis depends upon the height. This flow of air is just like water flowing in river. You know, water at the surface moves faster than water at the bottom. The same situation is happening here. Water and air both are fluid, you know, which can flow. तो यहाँ पे जो है इसकी स्पीड बढ़ती जा रही है, उसके अनुसार जो है x एक्सिस में स्पीड बढ़ेगी। तो I take this vx, velocity along x axis of the projectile, is directly proportional to y. Y is your displacement along y axis. This is y. So I can use a constant vx is equal to ky. So this vx is variable. Now this y is also changing with respect to time. If I consider motion along y axis only, केवल y axis में अगर मोशन देखें तो उसके अंदर एक सिंपल है कि ग्रेविटी के कारण ये स्पीड डिक्रीज होती जाएगी। At any instant of time, its final velocity will be equal to Vy is equal to u minus gt. This will be the final velocity, and the displacement along y-axis, that you will write s is equal to ut plus half at square. यूज कर सकते हैं हम यहाँ पे, क्योंकि एक्सेलरेशन along y-axis वो कांस्टेंट है, तो यहाँ पे that is ut minus half gt square. I have used minus sign. Reason is that speed is decreasing, the acceleration is negative, minus. So I will use the value of y in place of this in this situation. So Vx is equal to k into, putting the value of y, that is ut minus half gt square. This is Vx. Now if this Vx is constant, suppose it was constant, then horizontal range was very simple. Horizontal range was r is equal to Vx into capital T, time of flight. टाइम ऑफ फ्लाइट विल नॉट चेंज ड्यू टू दिस एयर ड्रैग. एयर ड्रैग के कारण टाइम ऑफ फ्लाइट पे कोई फर्क नहीं पड़ेगा, क्योंकि दिस इज हॉरिजॉन्टल, और इसके कारण वर्टिकल डायरेक्शन में इसका कोई इफेक्ट नहीं है, तो इसलिए टाइम ऑफ फ्लाइट विल रिमेन सेम. बट दिस Vx इज नॉट कांस्टेंट इन दिस सिचुएशन, इट डिपेंड्स अपॉन टाइम. सो वी कैन नॉट यूज this type of equation straight away, so we will use integration method. So Vx can be written as dx upon dt, and that will be equal to k into ut minus half gt square. Now you can integrate it, and x will be equal to k into ut minus half gt square into dt, and its integration from 0 to capital T. Capital T is our time of flight, when it will hit the ground, total time. And capital T, we know capital T is equal to, that is equal to 2u by g. So we can solve it. It will be equal to k constant outside, u t square upon 2 minus half g t cube upon 3, and this is 0 to capital T. We can solve it further, and then we get our result, horizontal range in this situation. So that this will be equal to r is equal to horizontal range, you know, represented by r. That will be, if I take t square as common, so this will be k into u by 2 minus g upon 6 into capital T into t square. Putting the value of capital T, that will be equal to u by 2 minus g by 6 into 2u by g into t square, means 4u square by g square. Here g cancel out, 2 3s are 6, u by 2 minus u by 3, it will be u upon 6 into 4u square upon g square. So we can further solve it to get the horizontal range, that r is equal to k into, this cancel out, this is u and this is 4, so this is 2 by 3 k u square upon g square, and